start a presentation. Lawrence is going to tell us about the intersection between natural language, if I understood correctly, and linguistics. And he wants to make this as interactive as possible. So if you have any questions, feel free to interrupt at any point. Thank you.
Yep. Cool. Hello, everyone. Can you hear me all right?
Yeah.
Is this mic on? I'm not even sure. Okay. Cool. So I'm going to be introducing you guys to what I find to be an absolutely awesome field called natural language processing, which is an intersection between language and linguistics and computer science. So yeah, let's go. So I'm going to start just with a little bit about me, and then we're going to talk about a little bit about what makes language awesome and extremely difficult, even though many people may not even realize, and then some of what makes this hard for computers, as well as how some important applications and how you could contribute to such a thing. Also, if you at any point, I don't have slides for everything that we could delve into, but anything that you think is interesting or have a question on, absolutely ask. I would love to delve into it, and whatever you guys find most interesting is what I'd love to introduce to you most. Cool. Yeah. So we're going to talk about NLP, natural language processing. So just a little bit about my background. Yeah, so I'm from Long Island, New York. And I was monolingual until like 6th grade, age 11, when I started learning Spanish in school. And in 8th grade, I got very obsessed with it and started only listening to things in Spanish, put all my devices in Spanish, translated everything ever to Spanish. And it was my absolute obsession. And I skipped a grade in Spanish and did a whole bunch of things related to that. And when I got to high school, my dad is from Russia, and I decided I was sort of interested in this and wanted to learn Russian to a degree, and there were some classes after school that I did for a little while. Never got super obsessed with it, but a little bit. And then when I was 16, in high school, I was super into my robotics team. And I've always really been into these geeky things like math and science. And in my robotics team, there was a team that came from Novo Hamburgo, Brazil, to our regional. And they, oops, no, we're good. And they told us they were going to come back the following year, and so I made it my mission to learn Portuguese as well. Yeah, and anyway, so then I go off to college, and I do not pursue this, and I think I want to learn something about prosthetics, and I think I want to do biomedical engineering, and that's what I go into, and after about a year, I realized I don't really know why I'm there, and I'm not that into it. And it doesn't really include the things I'm that passionate about, and I started thinking biology is very uninteresting. Anyway, also at the beginning of sophomore year, I started learning Hebrew. It was classes at school and also solo, and started listening to only Hebrew, like Israeli music for a while. Yeah, and then sort of everything changed like 2 years ago. I went to the Polyglot conference for the first time in New York, and it was an amazing weekend. And yeah, that made me realize with how amazing it was, how am I not including all these language things into what I'm pursuing? And yeah, and then also like 3 days later, I met who is now my advisor at school in computer science and is a wonderful professor and researcher, Jason Eisner, that introduced me to the field of natural language processing, which I promptly switched over into. Cool, and also studied linguistics a bit. Okay, so at Johns Hopkins in Baltimore. Yep. And then I was here at NAPS last year, which is no longer called that. Anyway, and then this summer, I had the wonderful opportunity to intern at Duolingo as a software engineer, which is wonderful. It's a great company. It clearly cares about all the things I am most interested in, interesting computer science applications to language learning and teaching people better. Yeah, all good. Okay. Cool. So now let's actually talk about what natural language processing is a bit. So the overall idea of like what the goals of NLP are is that computers are really useful at a lot of things. You could do number crunching, you could do lots of calculations very easily, you can make nice little interfaces and apps, and there's Uber and whatever else. But actually interfacing with the way people speak is extremely complex, and is something that people may not immediately realize. And it would be very interesting if we could do lots of these other tasks that are very language essential, like automatic translation, which is extremely difficult, or actually give a command to a computer in natural language and them actually do that on the other end, like the Star Trek computer or something. which Siri or Google now tries to do to a degree, but this is still very nascent. There's also other ideas like summarizing long texts. What if you want to do research, but there's so much text out there. You just want to know what is the essence of this subject you're looking into. There are lots of interesting ways that we can deal with the massive amount of text and language that there is out there. But the problem is that there's something about language that makes it extremely difficult for computers to deal with. It's not like doing integrals or whatever other mathematical concepts. It's just much harder. And the questions in natural language processing are, how can we teach computers about language? So as a short aside, I'm sure as an audience like this is aware of such a thing, but one of the most interesting things I think about language is that you need to explain why it's difficult to people. Because if I tried to explain to them why quantum mechanics is difficult, there would be no question. They're like, yeah, of course quantum mechanics and rocket science are difficult. Like, of course it'll take a lot of effort. This is insane research or whatever it is. But language, they don't think about. They were just born and they speak it, and they don't ever think about all the different array of things that something could mean or how they could have interpreted. And so this gets lost under the cracks unless you look into it a little. And people that study linguistics and NLP are hyper aware of this. Yeah, so some really interesting applications, which I beg you, if you have any questions on these at any time, we can delve into these for as long as you'd like. So there's some simpler, more conventional tasks, like spelling correction and grammar check or whatever that's like Microsoft Word does, which is sort of spotty, but exists. And autocorrect, which is just basically the same idea, like a little bit of a level above. Now let's just talk about autocorrect, let's say. So when they do that, they have to know what they think you might say next, which is interesting. If someone puts a phrase in front of you, you can often sort of complete it, which is very interesting and not something people generally think about. They just know what sounds right, what should maybe come next. But of course, this sort of thing is very messy. When you do fat finger typing, as it's called, you miss half the keys, but it still knows what you wanted to type because there's something inherent about the way the language is structured that helps them with that. So for example, they know what a word in English, if this is an English keyboard, looks like. Or they know what a phrase in English looks like. After, this is an example in, example in Hebrew, because that's what came to me. The verb to use in Hebrew is leishtamesh, and it's always used with the preposition be. So if you wrote something mishtamesh, the next word is almost certainly be. And this is just part of the context of what words have around them in general. And this is something we can take advantage of to make people's life easier typing, which is much simpler than some of these other applications, but yeah. Some other things are like automatic summarization. Now this is quite interesting because you could tell me about a situation in a sentence. You could also tell me about it in an essay or in an entire book. And the question is still inherently, what is the main idea? What is this about? And so this is just inherently a hard problem. There are so many ways to say things in different words. And the computer doesn't necessarily know these links between words that you can be taking advantage of to do in order to just reword things. So this is sort of like the overall idea of things that go on in automatic summarization. Again, if you have any questions. Then there are other things like search engine, for example. This is sort of related to a question answering system, which I'm going to mention. So a lot of the time people will have some question that comes to mind and they want it answered. Now, Google's pretty decent at this, but of course, not everything. If you want to ask something specific, what if you want to if you want to get the definition of a word, that's quite easy. You can search define X and the definition comes up. But what if you want to do it in the reverse way? What's the word that you use when you want to talk about that thing that's related to? Now, this is much harder because there's not just one way to say it. There are so many ways to say it, and the word has so many meanings, which is an inherent problem in, let's say, search engines. Also a very applicable thing that some research is going on in lately is analyzing public health trends. So a resource like Twitter makes it very easy to get massive amounts of data about what people are thinking at any given time because they share just a little bit too much. And so this can help us when they say, it doesn't help us too much when they say they're baking a cake or whatever, or they had the best day ever, which is wonderful, but yeah. But let's say there's some crisis, some flu breaking out somewhere, something or other. It is of extreme interest to know where is this happening, how fast is it spreading, do we know anything about it? What do people experience before and after? Maybe this is a new disease. This is the kind of thing that you could actually track using Twitter, which is entirely, I don't think like when they invented Twitter, they thought it would ever be used for trying to figure out what's going on in public health and diseases and how they're spreading. But this is the sort of thing that you can also take advantage of with some NLP techniques. So I will.
Before you go on to the next slide, quick question.
Yes.
I have my keyboard set to Canadian English.
Mm-hmm.
So if I write Dumia FABOR, it says no idiot, put in a U. But I do have my emails in French, and it just here you're missing accent grave, accent aigu, c'est. Why does it know when I'm writing in French instead of English? Is that my keyboard or is that Yahoo Mail?
Good question. So this depends on the interface you're using. So for example, recently there has been like more work in like bilingual keyboards, which is interesting. And this is different from just like the spell check, which I'm assuming which is what's going on in your computer, if that's what you're referring to.
But it does it in French and English.
Yeah. Yeah.
In the correct language.
Yeah, but Word doesn't recognize anything that I write. And because it's in Spanish, every time I write English, it's like red all over.
Mm-hmm.
So it just depends on what you're using.
Yeah. So like some.
Sophisticated their
Anything where I don't set my keyboard to French, so I can't put in a CD, ce contexte, I can't put in any of those. And it's always pointless. I just start writing in French. Salut Jean, écoute. And it goes, écoute. You need an accent aigu there. You know, it's always done that. Why does it know? I know, let's go back.
Yeah.
Good point.
If I may, that brings up an excellent point about something called language modeling in NLP, which is a really fun concept to introduce and explains this well, assuming they're actually, well, since they're not Word, this probably explains it because Word is, no. Anyway, so let's just give an example. So this is going to be an example of like, I want you to complete the phrase. So let's say I said, if you can read my handwriting, hopefully, yesterday, Joe ate blank. So what are the kinds of things, like what might you expect? What is the next thing that might come up in this phrase? Some. Yeah, you might say some. Soup, okay. Late. Yeah, he could have eaten late.
A or a number.
A, yeah, or some number. Yeah. Quickly, yeah. Yeah, or the names of so many different foods, right? With, yeah, he could have eaten with something. Yeah, he would have eaten with someone. He could have eaten with his best friend. He could have eaten with a spoon. And these are all very different, but these could all come up in the same context. So trying to figure out such a thing, your mind just does it, which is awesome. And I think one of the biggest things you do when you're learning a language is sort of building up this model of what might come next. And this is called language modeling in general. So there are like many ways such a thing might be done, and there are ways to do this better than other ways. And I want to pick your brains a bit on what you think might be some good methods. So for example, over here, let's talk about some of these things we have. So we have some and a. The would also fit in this category. These are called determiners. These are just the words that you use that specify a quantity of the item. Well, the number fits too, actually. And so these often start like noun phrases, and what you eat is probably some noun phrase. I eat potatoes, I eat fried chicken, whatever it is. And so this is often like ahead of such a phrase. And this is something you might pick up on and note that that's the sort of thing that might come after this verb. You might also notice like soup, and this is a noun, but it's not only a noun. It's a noun that's a food. It's a noun that's edible. It fits in this, what they call like a semantic frame. Like eating has a whole bunch of different things. It has the person who, well, I mean, it has the eater, it has the eatee, it has the instrument with which you eat. It could have been with a spoon. And different verbs have entirely different ones. You know, if I accused someone, or if many other verbs, they'll have different frames. And this is something you might want to model maybe explicitly. Because when you think about it, like what are do you have any, like, for example, reasons that these are things you came up with next, or just feels right? Does anyone have some explanation? Wondering. Yeah? They're common. Yeah, they're common enough. This is true, right? So, because the verb ate comes up very often. But I think the other thing is you also generalize. So this verb ate, you might have seen with all of these things. This is very plausible. You've seen the word ate so many times. It's entirely plausible that you've seen it with all of these words after it. But what if I use some obscure form or some obscure verb? Maybe you've never seen consumed quickly, or because consumed means similar to that, but it still fits in a similar frame. And so you might still want some of these things afterwards. While on the other hand, things that don't have a similar frame, like if you said, like, yesterday Joe left, you cannot end this with well, okay, that has an entirely different meaning, which is a great example. Yeah, I mean, you could not end it, and then it just means he exited the building. Or left soup, he left his soup there and should have cleaned up. Yeah, so these are just entirely different things. But something else that I think is an interesting point is, what if I, instead of saying yesterday Joe ate, I say Joe was tempted to eat something. Well, okay, not something, blank. How might you complete this, let's say? The same things. But is it really the same? Nothing, maybe? Cake, yeah, right. So maybe cake is a word that comes up much more saliently than here. Because this adding of tempted adds an entirely different flavor to the phrase. You no longer are just aware of him eating. You now know that he's eating, and also it's something he probably is embarrassed about eating or shouldn't be eating. And this just adds something to the flavor of, quote, flavor. Okay, flavor of the phrase.
Just as easily have Joe was tempted to eat with Sarah.
Yeah.
So it could be two very different things.
Yeah, but these both like refer to this.
Sarah's husband made that said.
But yeah, this is quite interesting, and it adds something new to this. Like, you can't just say we're modeling this exclusively based on the last verb that we saw, let's say, because that's just clearly not sufficient. You also need to know something about the entire rest of the sentence, and it's not necessarily clear if this is bounded or where you should end. The other interesting thing is that no one ever taught any of you to do that. You know, you were just born, and yeah, this is just obvious. You know, be tempted to eat cake sounds pretty good. He was tempted to eat chocolate also sounds pretty great, because you know you shouldn't eat that much chocolate. And so I think this brings up some interesting questions about like how you model this, which is really what NLP is like most concerned with. You come up with some interesting things you want to model. This concept is called language modeling in this particular case, but something interesting that you want to model. So you want to model what is the next word that might come up, because you're autocorrect, or you're that annoying person that finishes everyone's sentences, or whatever else. And the question is, how do you structure this? You want to build this in such a way that the computer could replicate this. You know, you can't just say, computer, could you like sort of tell me about words that come after eat sometimes? Because that's not a question you can ask a computer. You type things that are explicit, that are declarative. You say do X, calculate Y, in whatever language it is. It's very explicit like that. So you need to have something very well formed. So one sort of idea that people have on language models. Now this one actually won't be sufficient for this case, but this is a very common usage. Now it's something called Engram language models. So this N is stands just for a variable. So there are things that are like unigrams, or 1 gram, bigrams, 2 grams, trigrams, 3 grams. So the idea with those is it bases it exclusively on the words that have come before. So when it tries to figure out what came after Joe ate X, and if this is a trigram model, 1, 2, 3, then it considers you give it a ton of text, a very large quantity of text, and it does some statistics. How many times after Joe ate did it see some? Did it see soup? Did it see late? Okay. Did it see all of these things? And then, yes. They just see all of these things, and then you could just do some statistics. Oh, 30% of the time you saw soup afterwards, or 20% of the time you saw A afterwards, or something. But something about this just doesn't feel sufficient. Because why should you model Joe ate very differently from Mary ate? There is no difference there. They probably eat the same thing. Really, any name there sounds pretty good. So the fact that we're modeling these all differently is just like a little bit lacking. So something else that people will use is you can use like a combination of many of these. So you can do it like something that's a bigram model and also a trigram model. So you can maybe simultaneously take into account all the things you've seen after 8 historically and all the things you've seen after Joe 8. Now, of course, you've seen Joe 8 just strictly less than you've ever seen 8, just clearly. But it's possible that Joe might carry some signal in this. In this case, it's probably mostly noise, but it's okay because 8 came up so much more than Joe 8 that it'll probably play much less of an effect. Now, if we look over here in this case, the first thing is there's clearly something in common between these two. One is 8, one is eat. You don't really question it, but it's like, of course these are forms of the same word. The computer does not know they're forms of the same word. This is also something to take into account. Because while it's immediately clear to you, yeah, 8's just how I say eat yesterday. The computer needs to be told that somehow. And the inflectional system, the way you change words in a language is often highly complex. In English, it's simpler than a lot of others, but there are languages like Turkish where you can have a single word, quotes, that's really an entire sentence and goes on for an extremely long time. So you need to do some breakdown there. You can't just say something about that in isolation. Yes? Yeah, definitely. But this also has to do with the kind of model you make. This model is very naive. It's modeling 8 entirely separately from how it models eat. It doesn't even consider that these might be related. Which, unfortunately, a lot of these models are made by English-speaking people. And this is often sufficient for English, because English has no more than 4 forms of a verb. That's fine. You know, if you have 4 times more data, you're probably okay. You know, Spanish has 60, 70, whatever, depending on how you count, forms of the verb. Some languages have even more. Turkish goes on like forever because you can put an entire sentence in a word. So it's really important that you're aware of sort of like how these the regularity makes it much easier, which is why like a lot of this work happens in English and Chinese. With English, there's very little inflection. You know, you'll have eat, ate, eaten, and eats, and eating. Okay, was that 5 or 4? I can't count. But then in Chinese, you know, there is no sense of inflection. There is some character that represents eat. So if they want to do something like this, maybe it's not sufficient for other reasons, maybe word order or something else. But yeah, you could capture it okay with that. Unfortunately, since these are the languages in which most of the researchers actually work, sometimes it takes a while for them to actually make models that are more sufficient for other languages. So while maybe they find that the spell check that they made worked excellently in English, maybe it's really bad at Turkish. Because they don't take this into account. And that's something you'd like to fix. You know, you'd like to take this into account. And a crowd like this is extra able to know what are the kinds of things I might want to take into account. Because that's exactly what these sort of problems are. Yeah. So something else to think about here is something else that's very interesting related to language modeling, let's say, that you can do instead of this Engram thing. Is you could also do parsing. So have any of you guys had to like diagram a sentence when you were in school? Hands maybe? Yeah. I think this is like less recent lately, but yes, diagramming a sentence where you just take the sentence and you're like, and this is the, what are the words they use? Predicate, and this is the subject, and this is the direct object, and whatever else. And it probably felt, well, depending, I mean, this crowd might have liked it, but to most people, it probably felt sort of annoying. I personally loved it. It was my favorite part of 8th grade. But, no, Spanish was, correction. Yeah, so you can take advantage of things like that I'll just show you. So when we look at this Engram idea, it's all very linear. So you have some assumptions that the 3 words before you are somehow significant. Now this may not be the case. Think of a language like German where they put the verb at the very end of the sentence. It is nowhere close to its subject necessarily. So this like 3 words away hypothesis is probably really a bad one. Because whatever they put in the middle will dilute the whole signal of this whole thing. And this is just not something you'd like to ignore, because it'll just make you model the whole thing worse in a language where this is the case. So a different idea has to do with parsing. So that's putting like a tree structure over the whole thing. So let's start with like this yesterday Joe ate X. I'm just going to go with your soup option, and we'll put that here. So we sort of just build a tree over this whole thing. So we say ate soup. This is a verb phrase. And we say Joe is a noun phrase. And Joe ate soup is like a sentence. There are lots of different formalisms for what you might use as these labels. And you can have many more interesting labels that explain this better. But this is the very simple version. And maybe you are like, oh, and this is an adverb, and you could just match those on sentences. This is probably not a good version of the grammar. There are many better versions of the grammar. But this is a very simple one. So let's say we said that. You can take a sentence and put an adverb on it to make a sentence. Yeah, so you can actually do a lot of modeling like much better this way, especially if you add something else that's like a head. So the head of the verb phrase is ate. So you can do some reasoning about that. So even let's say a lot of things might come in between these two. Let's say someone's speaking in very odd syntax, which might be acceptable in other languages, but sounds like Yoda in English. So maybe you said, yesterday Joe ate with a spoon some soup. That's not really very okay in English, but in other languages this would be okay. The distance is farther apart, so this like number of words away hypothesis doesn't work as well. But whatever the head of the phrase does, because the stuff in the middle won't affect who's the head of the phrase. The head of the phrase it's still a verb phrase, and you're still talking about eating. So you can then try to model it maybe that way. And this could be a better formalism, potentially. So then, even if the word is very far apart, or like in German, where the verb will be all the way here at the end, and the whole rest of the sentence is, well, I mean, okay, probably be more like that. The whole verb phrase is towards the end, and the subject is at the beginning. Even though they're nowhere close to each other, you can link them. And this is a much better formalism. And you could use this in a more interesting way. And this is basically the kinds of problems that you might want to discuss in NLP in general. How might you want to model things? What is your model missing? What is it not noticing? How could you do that better? Etc. Especially in cases where you don't have a ton of data. The other thing is sometimes people cheat and do things that are less interesting because English and Chinese, where they do most of their work, has just a ton of things on the internet. And they can get away with, it's like, oh, we're not going to model, let's say, that ate and eat are the same thing because they came up so often on the internet that we just don't care that much. We'll model them separately, and it'll be enough data to cover both of them. If this is Spanish, it may very well not be the case. Catalan's even smaller. It's very well not be the case. Yeah. Hello. Yeah, so I mean, so this whole idea of this language modeling, right, is useful for a host of tasks. So let's say one of these tasks like we were discussing is like this autocorrect. Autocorrect, if it uses this as an underlying language model, the things it thinks might come next in English, or what it thinks makes a well-formed phrase in English, or in German, or in Catalan, or whatever language you might be making this for, this could just make it be better able to capture these parts of the language, which other models might be worse at, or yeah, etc. Because unfortunately, again, a lot of English and Chinese speaking researchers that miss a lot of these, let's say. Yeah, this is also useful for another up-and-coming thing is machine translation, like Google Translate, let's say. So I think we all know that it is not sufficient right now, and I don't know if it'll ever be okay, like useful enough to just like, you know, I'll throw my news article in there and hope it's okay and publish it. But I don't know if it'll ever hit that point, but it clearly isn't right now. There are a lot of things about it that just don't transfer one end to the other all right. And this has to do with like a lot of these problems. So I have a couple examples that I think are quite interesting that I think may help. Hello. I'll temporarily skip this, but there are some interesting things to talk about there. Okay, so I'm going to bring up this fun dialogue example. Just extra examples of why language is really hard, and you may never have thought of it, I think these are the examples where even people that love language learning may never have thought of it, because this is at the level where it's no longer focused on the language, but the act of communicating. And that you don't think about really at all. So let's say we have this dialogue. This is you and your friend, and your friend says, "Do you want to go see the new Batman movie tonight?" Your response is, "I have a test tomorrow." He says, "Ah, I understand, maybe another day." Now, this is quite interesting. You never actually responded to him. You didn't say you didn't want to go. This never came up. But of course, he knew what you meant. But how did he know what you meant? If you fed this to a computer, how would it know what you meant? Because this requires a lot of logic to go from one end of this to the other. So let's just try to like ride this train through. So there's a movie tonight. Okay. So what does that mean? Well, movies take time to watch, maybe 2 hours, 3 hours, getting there, eating dinner, whatever, maybe longer. And what else? This person B has a test tomorrow. Okay. And one needs to study for tests, ideally. One of you is a responsible student, otherwise you wouldn't have even brought up that you have a test tomorrow. You would have said, yeah, let's go. And you also note that one needs time to study. And then also, usually a couple hours, maybe longer, maybe similar amount of time that you might have spent on the movie. And also that, yeah, the movie would also take a couple of hours, and that you cannot complete both of these things at once. The time is mutually exclusive. Although you might try to convince yourself you can watch the movie and study for your math exam, it's probably not happening. And so, no, I pressed the wrong button. And so that's all the time left tonight, and so you've concluded that B cannot watch the movie tonight, and that he declines. Now, this is quite interesting. There was a significant amount of logic that went on there, and none of you would have considered it, probably. I mean, no matter what language you're learning, this is something that would definitely go under most people's radars. If you learned whatever language it is, and you understood what all the words meant in that phrase, you understood he was saying he or she had a test tomorrow, you would understand, yeah, of course. All these things just go by in your head, this instant calculation, you don't even consider it. I think this is very akin to, you'd be very impressed if there was a giant, ridiculous formula on the board, and you looked at it and instantly knew the solution. But that's exactly what you're doing. And this is extremely complex, and it brings up questions of, if I wanted to teach a computer to follow me in this dialogue, if I wanted to make a chatbot, let's say, how would I even begin to do that? I have no clue how I do that. Yeah. So this becomes extra important in, let's say, like chatbots. This is something people think are really cool lately. Now, chatbots? Oh, okay. Sorry, I'm going to circle where this gets discussed a lot. But yes, so chatbots are just like, if you make some computer program where you can talk to it and it'll respond to you. So people are using this for lots of applications. So some of it are like, I've seen some startups that are trying to do stuff with chatbots to help people like with mental health, like they might be suicidal or have depression, to talk to them and this is automatic. There's no person on the other end, but it's automatic and might try to help them. Or Duolingo has chatbots they're trying to use to help people learn languages, or there are many other such applications. Maybe it could be a question answering system. You talk to it and you ask it questions. Maybe it'll teach you a class. This could be anything. The idea is that you make an artificial entity on the other end of the discussion that you get to talk to. Yes, customer service, absolutely. Yeah. Hello? Oh, that's less than ideal. Oh, there it goes. Okay. Yeah. So if you try to make a chatbot, it very quickly becomes very evident that you somehow need, well, okay. If you had like this free-form chatbot that you can say anything to it, and it would actually be able to respond, sort of like you, let's say, then you would have to somehow encode all of this logic. And you would have to come up with some way to do that. Very interesting. Because it's not apparent how. Because how did you know these things? Do you have any, why did you know all of these things? Oh yeah, you're inferring lots of things. Not all of these are set in stone. Maybe your friend doesn't need a couple hours to study for the test. Maybe he's already studied a lot the last couple days, and he just needs to spend a little while. So maybe you actually guessed wrong. This could be true. Maybe the movie's actually extremely short, or maybe it's very early in the day, and you can do both. There are lots of interesting corners. this isn't necessarily set in stone, right? So that's one thing. Another thing is all of you learned this just by existing. You know, you've existed, you learned, you sort of understand how time works as a function, like as a concept. I mean, some of us could do a little bit better at organizing ourselves around it. I definitely could. But it's something you know, you understand as a concept. You understand what tests imply. You've taken tests before. You know that you need to study. If you don't, you'll likely do badly. You wouldn't want your friend to do badly just to watch a movie. You could watch a movie another time. That's okay. You know, you have empathy for this other person. Yeah, you understand that you can't do both of these things at once. You may very well have tried, and it did not turn out too well. Or maybe it did. I don't really believe anyone can do these both and be okay, but maybe your friend can. I don't know. And yeah, all of these things are things you just learned by existing. This is like world knowledge. You've just been around for a while, and this is just stuff you know. But how do we teach a computer world knowledge? You don't know how you learned world knowledge. You were just here for a while, and you know, you just sort of know this stuff. And no one spoon-fed you every one of these details. Like your parents never went to you and said, well, okay, to some extent they did, right? You need to study for that test. Okay. Or your teacher said, I don't think anyone told you time is mutually exclusive and you cannot do two things at once necessarily. You probably just figured that out yourself. No one had to spoon feed that one to you. Yeah, and the amount of time left in the day, some sort of sense for all of these things, this is stuff you just got by existing. So here's like another example that might be interesting. So let's say you said, oh no, I can't reach that cup high up in that shelf. And then B says, oh, we should invite C over next time. C's a basketball player. Oh, I lost one. Where'd it go? Yeah, C's a basketball player. So of course, we have another fun logic train going. So first of all, you can't reach the cup that's on the shelf. Now this brings up the question, why can't you reach it? You can't reach it because maybe you're not tall enough? Well, there are a couple options. You're either not tall enough, let's say, or you could be tall enough if there were a step stool, but there isn't one. Okay, so this is an option. And then your friend responds, but that we should invite over C next time, which almost sounds tangential. You know, he didn't respond with something to help you with the shelf. He said, oh, C's coming over, which of course you connected the dots since C's a basketball player. Basketball players are usually quite tall. Tall people can help you pick up things from shelves, and boom, you're done. Excellent. This is not something the computer would know, again. So this brings up questions. How do we teach a computer? You just sort of existed for a while and you got this. Yeah. Also, if anyone has any fun ideas or questions, let me know. Yes?
Well, this reminds me of a sketch by Key and Peele where they're texting back and forth, and one guy wants to say something, and the other guy reads the text but thinks it means, you know, something very negative instead of positive. Like, you know, there is going to be, even in our language now, with people that we're very familiar with, there's always going to be things that we guess at and try to figure out next time, and it's all, I guess, percentages of whether we're going to get it right or not.
Yeah.
So my impression would be you have to make the computer's world, you know, start off with it very small, and you're only ever going to be able to take it, you know, so far.
Mm-hmm. Yeah? Intonation. That is like sentence level intonation or intonation like in Chinese in the tones? Okay. I don't personally study speech that much. There's a lot of interesting stuff going on in ASR. Mm-hmm. Yeah. Mm-hmm. Yes. Given a vocal inputs. Yeah. So I think this is, to my understanding, this is an extremely unexplored area of research. At some point last summer, I was doing some stuff with speech recognition, and I thought about this quite a lot. I'm like, how would I represent intonation? Because it's not immediately clear. It's not like, oh, I could just say it was high. Their voice was high or their voice was low. I mean, there's this whole like function thing going. It also depends on the person. Some people's voices are higher than others. Some people have more variation than others. So there are lots of things going. I'm not honestly totally sure, but I think that's the interesting part. We're not sure. And that just means there's a lot to research. And if any of you have thought about this a lot, or if my presentation has helped you to think about this more, you could contribute to this. I think it's a really awesome field, and you could do research in it. Yeah. On dialects. Oh, sorry, I missed the last sentence. Dialects and accents. With relation to speech recognition. Mm. Yeah. You mean in terms of ordering? Yeah. So I'll talk about the dialect thing first. I think this is also a very nascent area of research. Yeah, because it's often the case in a lot of these NLP applications, the standard version of the language is really the only one that's considered. Or if, British English and American English, these standard versions, which isn't necessarily sufficient. People don't talk that way necessarily. In different communities, they might speak with different words in different countries and different cities. And this is ideally something you might want to capture. So let's just go through some ideas of maybe how you could capture such a thing. Oh, it doesn't go that way. Okay. A what diagram? Yeah.
The one that says semantics.
Yeah. Yeah. Oh, yeah. Yep. Yeah, absolutely. I'll bring that up and use that as reference here. Where are we? There we are. Yeah, I will temporarily skirt explaining all of this and explain it as we go. But in a very loose sense, this is just sort of like layers of language. So this starts in this like very small idea of just the sounds you produce. Just exactly what you hear, whatever those sounds are. And then this goes up a layer to phonology, which is how sounds interact in a language. This also brings up things like phonotactics, which are which sounds are allowable where in a language. So for example, like Japanese doesn't allow consonants to end a syllable, which is why, if they try to say, if they take ice cream and loan it into Japanese, it'll be like aisukaimu or something, because they just cannot allow such a thing. Or why in Portuguese they say snappy shachi and Facebook and YouTube, because they also, it's part of their phonotactics that they can't end a lot of syllables like that. So that's something over there. Morphology is up another layer, which has to do with the parts of language, the sort of sub parts of words and such. So for example, if I said, you're a hard worker, so worker is, derived from work, and this morpheme is the word for it, that you can link together to make it one who works. Or you can build this up even a bit bigger, a word like unacceptably. It comes from accept. Accept, able, means things that can be accepted. Cannot. Li, as an adverb. You can build this up together. That's like morphology. Syntax is what we're talking about over here with these syntax trees. Sort of talks about how, basically defines like the bounds of word order and how that works. Semantics is a layer over that just has to do with meaning itself. And pragmatics is a layer over that, which has to do with what's in between the lines, which is what we were discussing in that dialogue example. Yeah, so in terms of talking about dialects, yeah, I mean, they could differ at lots of different levels of this. So, don't freeze on me. Come on. Okay, it'll come back in a second. Okay, yeah, so let's start with, okay, some initial assumptions. If you wanted to model this, let's say you wanted to make some system that does speech recognition. And you wanted to do it such that, let's use Portuguese as an example. One of my favorite parts about Portuguese is the extreme level of variance in dialects. People pronounce things lots of different ways in lots of different cities, even just in Brazil. I mostly have just focused on Brazil, but then also in Portugal and Angola, Mozambique. And there's like a lot of variance there. But of course, there's also a lot in common. Ideally, if you're modeling this, you want to take into account both of these things. You want to encode somehow how they might differ, and also keep all the things that you can in common. You don't want to like waste effort in learning the same things twice. if you make the system, you can take advantage of a lot. Let's say you, as training data, have people speak of the Carioca dialect from Rio, and you also have people that are from Sao Paulo, the city, and also from Sao Paulo out in the countryside. They speak very differently as well, or all around Brazil they speak differently from each other, and there are lots of different ways these differ. So one small example might be, so like in Rio, for example, they have this thing called chiado. So all the S's that end syllables, they make it into a sh. So, for example, instead of saying, one of the best things ever, churras is like Brazilian steaks, best. But they'd pronounce it in the plural as churras. Ignore my accent because I don't try to speak like a Carioca. I go for the Sao Paulo dialect. But anyway, yeah, so they might say it like churras, and maybe this is something you just encode. Well, there are lots of ways you might do this. Let's say you're explicit about it. You're like linguistically informed about it. You could, let's just assume you have some model that you might do speech recognition with. You could encode somewhere that something very specific about like the syllables, shu, hus, or in Rio, shu, hush. And maybe that's something that you encode very explicitly, like I was saying, that if the S is at the end, we might pronounce it like a sh if we're in Rio, but also if we're in Portugal, actually. So that could be something you do. And this is down at the layer of like phonology. Yeah, like because this doesn't occur if the letter is in other positions, it has to do with position a lot. So that's one thing, let's say. There's also stuff related to morphology and syntax. If you wanted to say, like in Portugal, the way they say I am doing is different from the way they do in Brazil. In Portugal, they say estou a fazer, and in Brazil, they say estou fazendo. So now this is on the level of morphology, the shapes of the words and how they use them. But if you wanted to encode this, let's say, right, you want to make a system that can simultaneously be, an equal access speech recognition. It doesn't only understand the people from Sao Paulo and entirely ruins what the people from Rio say or the people from the countryside, because people don't usually like it when the system doesn't understand them. The speech recognition almost never understands my dad with his Russian accent, almost ever, which is just unfortunate. Ideally, this would be better. Yes, so yeah, so you could encode. Okay, the overall idea is that when you're modeling such a thing, you want to point out the places where you think there might be variance. So you say, well, it depends. There are some ways of modeling things where you treat the entire thing as a black box and just shove it all in there. The problem with that is you don't necessarily know what it will or won't learn. It might learn something that is entirely wrong, or it might learn something that you didn't know how to encode yourself. But on the other hand, it could just learn this relationship. But a way to do it that I think is really interesting in a sort of overall sense, something I think is awesome called graphical models that I've been looking into more recently. So the idea of this is a probabilistic model. Probabilistic meaning like nothing is certain. There's some probability that someone does that. There's some probability they order their words this way. There's some probability that when they meant to say sh, they said s. This might not necessarily be the most accurate formalism, but it captures a lot of in-betweens that we could take advantage of. So let's say we wanted to do such a thing, and we actually take into account how these different dialects are related. So you could have an overall idea of Portuguese. And you have Brazilian Portuguese, and you have Portugal Portuguese. And within Brazilian Portuguese, you might have some relations that in Sao Paulo, and in Rio, and in Rio Grande do Sul, it's the southernmost states. And you sort of connect the model like this. You're putting in your assumptions about how you know this works. You know that there's sort of this idea of general Portuguese, but you've never seen it. You know such an idea exists. There's something that's in common between all of these. When I cross this over, it means you've seen it. It's something that you actually encounter. You've encountered Portuguese from Portugal. You have not encountered, and you've encountered, well, actually, no, you have not encountered a general Brazilian Portuguese, ignore that, but you have encountered all these dialectical versions, let's say. And you can create such a model where you encode these things that you know exist. You know there's something general about Brazilian Portuguese that you can talk about. And you know that there's something about the state of Sao Paulo, let's say, or however you encode it. And you could use that in order to model it better, such that when you learn something more about Sao Paulo dialect, it'll also transfer it over, and you could learn more about the Portuguese in Portugal. And this is sort of a very high-level idea of how such a thing might be done. In different dialects, or in... Yes. Okay. So once again, open area of research. If you have lots of ideas, there are so many things you could talk about. But yeah, so if you wanted to talk about, so the idea of this is called, well, okay, maybe polysemy is not the right word, but polysemy just means words that have multiple meanings. So this is just apparent even within a single dialect. Let's say I say, the stolen painting was found by the bank, if that's even remotely legible. The stolen painting was found by the bank. Now, is it that we found this painting, it was stolen, and we located it right near the river? Or was it that the people from the bank came, and they actually located their stolen painting? The same word, but different meanings in different contexts. And over here, both are legal. So now if you're modeling this, let's say not even talk about dialects. Modeling this, because if we talk about this, then we could maybe abstract it and talk about how we might deal with this with different dialects. You notice different things that vary. By has multiple meanings. By can mean nearby, by the bank, by the riverbank. It could also mean like sort of on behalf of. The bank is the one that did it. They're the agents in this. And so this is something you can encode in, yeah, so, oh, okay. I'll go on this real quickly. But yeah, overall, this is something that you can encode. And let's say, this is the sort of thing that you would deal with sort of simultaneously with parsing and coming up with a tree for this. Because what this, which sense you choose is sort of influenced by the tree structure you choose. In this case, they're the same. There are a lot of cases where this is not true. So this is something you might encode, that the word 8 might have multiple meanings. And one of its meanings is compatible with this syntax. And one of its meanings is compatible with a different syntax. In your case of sick, or this version of by, or the bank, that's not the case. But you can also talk about sort of compatibility between words. So you know if it were riverbank, no question. You know what it is. So you can model that. So let's say in the tree, you notice that river and bank are in the same subtree. So this might tell you there's only one version of river, but there are two versions of bank. But this one version of bank is much more likely with rivers than with people with money. So you can use that to take into account. And if you did something with dialects, I'd have to think about it more, but there are lots of ways you could take advantage of this.
But then there's a time you have to teach the computer to think. So what I'm hearing is teaching a computer to speak language is much harder than teaching it to play Go.
Oh, absolutely. Even though that Go thing was an extremely, well, we could talk about this offline if we ran out of time, but the Go thing was an extremely interesting task. But also, there are only like two things, there's only one thing you can ever do in Go. You put down a piece. Over here you have to build, and you have to, and there's no illegal moves, I don't think, correct me if I'm wrong. Well, there might be some constrained place you can place words. But over here, you could say lots of things, but the aim here isn't just to produce words, but to think of what you want to say and produce the words that will convey that. So you're trying to do this transfer in my head to communicate it in words. And this is just clearly a very fuzzy problem. And there's a lot that still needs to be done to make this better. But yeah.